When the Webb observatory turned toward a faint, fast-moving visitor, scientists braced for the ordinary: frozen dust, volatile gases, a comet's familiar breath. Instead, they found something that refused to fit any known script. The object, catalogued as 3I, Atlas, arrived on a path that left no doubt. It came from beyond our sun and would not stay. Its trajectory was unmistakably hyperbolic, a single, unbound sweep through the solar system. But what caught the team's attention wasn't just where it came from or how quickly it moved. It was what it was doing. Deep in the infrared bands where Webb excels, a narrow, persistent beam of light was present. Not a diffuse thermal glow, not a scattered reflection, but a focused emission with surprising regularity. The signal held its shape as the object tumbled and rotated. It didn't flicker or blur with changing viewing angle. It maintained a rhythm, an on and off cadence, and a spectral cleanliness more like an engineered emitter than a random natural process. At first, the reaction was familiar. Check the instruments. Cross-compare exposures. Rule out cosmic rays, calibration errors, or software glitches. Multiple teams repeated the measurements and left little room for simple mistakes. The glow came back on new exposures. Different spectral bands confirmed the effect. Background sources were excluded. The more carefully the data were examined, the less it looked like an accident. Natural explanations were tested against the evidence. Could exotic chemistry, fluorescence, or unknown outgassing produce such a concentrated output? Could crystalline surface effects or uncommon reflection geometries mimic coherent emission? The answers were not definitive, but each proposed natural mechanism strained against the numbers: the narrow bandwidth, the steadiness despite rotation, and the sheer apparent power implied by the infrared flux. As the list of plausible natural processes shortened, the possibility that the emission was engineered moved from a fringe hypothesis to the centerpiece of discussion. The signal's traits, coherence, directionality, and temporal regularity, are hallmarks of design sources. Simulations that assumed rotating emitter arrays, stabilized beams, or patterned surface elements reproduced many of the recorded features. Models that relied solely on chaotic, volatile activity did not. That is a large claim, and scientists have always been cautious about leaping to extraterrestrial explanations. Yet the data forced hard questions. If not nature, then what? One working hypothesis gaining traction in some circles was unambiguous in its audacity. 3I, Atlas might be a probe. A relic or active device sent from far beyond our system to observe, transmit, or navigate. Why a probe? For one, the emission looked as if it was deliberately focused and possibly aimed. For another, there was little sign of waste heat one would expect from inefficient engines or uncontrolled disintegration. The geometry of the emission often appeared localized to specific surface regions, producing a beam-like pattern rather than a spherical wash. Those features, taken together, invited speculation that the object carried hardware designed to survive long voyages and to operate with high energetic efficiency. Still, the community split quickly and predictably. One camp urged restraint, pointing to rare materials or processes we simply don't yet understand. Others argued the data were compelling enough to treat the artificial source hypothesis seriously. Papers and preprints proliferated, each applying different models and testing alternate assumptions. The debate expanded beyond spectrograms into polarization measurements, light curve analysis, and even geometric reconstructions aimed at inferring surface structure. The timing of the detection only deepened the drama. 3I, Atlas was fast, so fast that the window for observation was brief. Months, days, and then hours mattered. Ground-based observatories from both hemispheres rushed to add their eyes. Hubble and large optical telescopes tracked its changing brightness. Radio arrays listened for anything that might accompany the infrared signal. handful of facilities reported subtle, structured brightness variations and polarization signatures that seemed to echo Webb's initial finding. None matched Webb's sensitivity in the infrared, but the corroborating hints gave weight to that did not silence the skeptics, but it did widen the conversation. Astronomers, engineers, and theoreticians began to ask bigger questions. If this is a tool rather than a rock, what is its mission? Is it a passive recorder left to drift? An active scout scanning systems it passes through? A beacon meant to be noticed by emerging intelligences? The possibilities multiplied quickly and wildly, each carrying profound implications. If 3I Atlas were designed to be found, the game changes. It suggests intent. Someone, somewhere, hoped their work would be observed. If it was meant to be seen, why choose such a subtle, narrowband signature instead of a bright radio shout? One answer is also a lesson in detection. Many natural and artificial phenomena are invisible until you have the right tool pointed at the right place at the right time. Webb's infrared sensitivity is not a magic lens that only we possess. It's simply the instrument that happened to intersect the object's emission profile. The social and philosophical impact rippled outward almost immediately. For some, the possibility of an engineered interstellar object brought wonder and the promise that curiosity and craft extend beyond Earth. For others, it stirred caution and unease. A deliberate signal could mean we are observed by something more advanced and perhaps indifferent or protective of its distance. Policy discussions began behind closed doors. Governments and space agencies considered options that ranged from purely scientific follow-up to more ambitious thought experiments about active response. Should we transmit a message? Should we remain silent? Do we analyze and archive everything we have and accept that the object will leave, perhaps forever? There were no easy answers. Practical limitations were stark. At current launch and propulsion capabilities, intercepting a small, fast object on a one-off passage through the solar system is almost certainly impossible. Even if a rapid mission were technologically conceivable, designing, funding, launching, and catching a target on a hyperbolic trajectory would take years and miracles, time we did not have. So the work fell to telescopes and to human ingenuity in data analysis. Every photon Webb captured became precious. Researchers combed the archives and reprocessed exposures, searching for hidden structure, binary timing, or encoded patterns. Teams used machine learning to hunt for signatures that might indicate modulation or embedded information. Others focused on building physical models that could replicate the narrowband emission without invoking deliberate engineering. Diverse approaches proliferated because extraordinary claims demand extraordinary scrutiny. Even if a definitive answer never arrives, this episode changed how humanity looks outward. It was a reminder that the cosmos still holds surprises that can, in an instant, reorder our assumptions. Whether 3I Atlas is an engineered emissary, an exotic natural object, or something in between, its passage pressed us to sharpen our tools, extend our cooperation, and think carefully about how we respond to anomalies on the edge of what we can know. For the moment, the visitor fades. Its signal weakens as it speeds away, returning to the interstellar dark from which it came. What remains is not only a dataset but a question that will reverberate through science and culture. Did we witness a message, a machine, or a mystery that simply outpaces our present understanding? Whatever the answer, the detection, real, ambiguous, or misinterpreted, has already done its work. It pushed humanity to listen more closely, to coordinate more widely, and to accept that the universe may be stranger and more populated with instruments and intentions than we once believed.